All right, welcome back. Chapter 7, clip 2. And so we've been looking at returns and risk, and now let's put together risk and returns and a normal distribution. Let's take a look at a normal distribution. So a normal or a probability distribution can be used along with the mean and the standard deviation to predict the likelihood of outcomes. Okay? So using a normal distribution table, an outcome will occur between plus or minus one standard deviation of the mean 68% of the time. All right? So there are three statistics relating to a normal distribution that I want you to remember, and the first is that an outcome will occur plus or minus a mean. So you have your mean, and then you have plus one standard deviation, minus one standard deviation. So that area in between, 68% of the time, an outcome will likely happen. 68% of the time it will fall into that area of between plus one standard deviation and minus one standard deviation of the mean. Particularly as your sample size grows, the likelihood, your confidence level in your likelihood grows as well. So now as you add two standard deviations above the mean, two standard deviations below the mean, the likelihood of your outcome falling in that range goes up to 95%. Okay? So 68%, 95%, and plus or minus three standard deviations, just about 100%. Okay? And so here's a table or a chart that shows what this looks like. So 68% of the time, when you know the mean and the standard deviation, 68% of the time with a normal distribution, your outcome, your event will fall in this area. 95% of the time, two standard deviations, and 100% of the time, three standard deviations. So we're going to use this information to predict or to determine the likelihood of an outcome. All right. We're going to have to compute the z-score. Okay, remember this from statistics, computing the z-score to determine the probability of an outcome. So let's look at an example, and again, we'll have a homework example and we'll have one of these on the exam, but it won't be too complex for you. You can do this. All right, so what is the likelihood that the annual return will be greater than 0? So given a certain mean and a certain standard deviation that we've already calculated, we calculated the mean to be 8% and the standard deviation to be 6.13%, okay? We have to calculate the z-score. So the z-score is our target return minus our average return, and then divide this number into the standard deviation. So let's take a look at doing the z-score. All right, so the z-score determines the standard deviations from the mean. Okay, here's our example. We calculated the mean return in our previous example to be 8% and the standard deviation to be 6%. All right, so let's put that together along with our target rate of return of 0%. All right, so let's see. So our z-score, where's our z-score? Where's our z-score? Let's count. Okay, here we go. So if the mean is 8% and the standard deviation is 6%, okay, then a return of 0 is 0, our target rate of return, minus our mean rate of return, then divide that into our standard deviation. And our z-score is minus 1.3 standard deviations. Okay, there we go. Got off a little bit. Okay, so there's our z-score. Now we have to go to the normal distribution table. Here we go. Here's the normal distribution table. So here's our mean. Okay, and so our mean right here, let's see if we can fill this in. 1.3. Let's get these numbers in here. I want to get these numbers in here. All right, so this is minus 1.3 standard deviations here. Okay? So what we're saying is, what is the likelihood that will be above 0? 0 or greater, okay? Or 0 or less than 0. And so this is the likelihood, this is the area that is covered, that will, given a mean of 8% and a standard deviation of 6.13%, the likelihood is that will fall in this huge area in here. Okay, folks? So we go, here's our z-score, and we go down to 1.3, and then go over here, and we find that we have a 90% chance that we will earn 0% or greater, which means there's about a 10% chance here on this side that, given a mean of 8% and a standard deviation of 6%, there's a 10% chance we'll have a negative return, and there's a 90% chance that we'll have a positive return. Okay, so you have to decide as an investor if you like those odds. Are those odds good enough for you? Okay. All right, so there's a 90% likelihood, given a mean of 8% and a standard deviation of 6%, that the return will be greater than 0. All right, so that's how you put together the mean, the standard deviation, the z-score, and a normal probability distribution. Okay? All right. So we're going to clip 14, 2 more clips, 2 more slides. All right, looking at portfolio risk. So we've already calculated that, or learned how to calculate the expected return of a portfolio. It is simply the weighted average of the expected returns of each individual security, okay? And they sum that up. But the standard deviation of a portfolio, the risk of a portfolio, is not simply the weighted average of the standard deviations of the individual securities in the portfolio. What I'm saying is computing risk is not the same as computing return. Okay? This information, the weighted average of the standard deviations of the individual securities, is only part of the equation. To calculate a portfolio's expected standard deviation, you must also know the extent to which asset returns will be associated or will move together. Okay? So to do standard deviation, we need to know the standard deviations of the individual securities, we need to know the weightings of the individual securities, and we need to know the correlations of the individual securities, how they move together. All right. Correlation measures the degree of association between returns of assets. How do the returns move? Do they move together? Do they move apart? Okay. Correlation ranges from -1, which is perfectly negatively correlated, to +1, which is perfectly positively correlated. All right? So correlation is 1 when returns move exactly together. Therefore, adding assets that have a correlation of less than 1, and this is a key question, a key concept, you do not have to have a correlation that's negative in order to add diversification to a portfolio. You simply need to have correlation that is less than 1. Now, it is true that the lower the correlation coefficient is, the more diversification you add by adding those securities together. All right? But all you need is correlation of less than 1 to add diversification to a portfolio. Okay? Because the assets do not move together. All right. Correlation of -1, as I mentioned, happens when returns move exactly opposite from each other. And assets that have a correlation of -1 are said to be perfectly hedged. An asset goes up 1%, and a perfectly hedged asset goes down 1%. Okay? And because of this, there is no variability of returns of the portfolio because the portfolio doesn't move. The movements of each asset exactly offset one another. Okay? So bringing together assets with a -1 correlation renders a portfolio risk-free. But then the question becomes, can you earn any return with those assets? And I'm not exactly sure mathematically that you can. Doesn't seem like you could. Okay? Maybe there's a way to prove that you could. All right. So let's see. We're going to stop there, and we'll move on to the next clip and take a look at how to finish calculating the expected standard deviation of a portfolio. Shalom.